Okay. So for a starter, and you could have gotten around this by using the peak function, but where's my pop? Yeah, right here in pop, I was not decrementing count. So I think that's on Klancy. All right, so let's now go into our driver. All right, so at this point, let me just confirm that our, I'll just dump our stack here for a second since we tested it. Didn't really test pops very well, but is what it is. Let me just confirm that we are Yep. Okay, so there's our tokens. So we want ShuntingYard to start processing through this. And for ShuntingYard, we're going to need a couple of different pieces. Let's see, do I actually have a ShuntingYard? I don't. So what we're going to do is we're actually going to give ourselves a ShuntingYard object that we can pass our initial string into, as well as the operators, and it will do all of the magic. So we'll go ahead and create a ShuntingYard.hpp. And we'll add the stuff there at the top as we come across it. So we'll have a class called ShuntingYard. And inside here, we'll have our private section where we'll have, so I need to bring in pound include H and using namespace STE. All right, so we're going to have our string, let's call it expression. We'll have our string delimiters. Isn't string in string.h? Or is, oh, it's this. Okay, so because this is the namespace. So we'll have those two guys and we'll start writing our public pieces. So public will have a constructor for this, ShuntingYard, and this guy will take in a string expression and a string delimiters. And actually, that's all I'm going to write for the moment, just so we can test it here pretty quickly. And then I'll go ahead and add my ShuntingYard.cpp. And inside here, we will go ahead and implement our constructor. And we need to include our HPP. And let me confirm something here. Did I? Okay, I did put a semicolon at the end. All right. Now what I'm going to do in here is basically suck in all the stuff that we're currently doing inside of driver. So I'm going to need my queue, and I'm going to need my stack, and I'm going to need my string factory. So I'll steal those from there, and we'll put that into our ShuntingYard dot. Actually, I'm going to put it into our ShuntingYard dot CPP. That's where we're actually using them. We might move it later on, or we'll put it in multiple places. Back to driver. So I'll go ahead and keep those, but I'll say move our queue and stuff into ShuntingYard. We'll do it in the constructor. And we'll come back here in a second. So then out here, I'll go ahead and create a ShuntingYard SY, or ShuntingYard pointer. SY is equal to a new ShuntingYard, and we need to include ShuntingYard HPP here. And this guy's going to take in our string and our ops. Okay, and then inside of ShuntingYard CPP, we'll go ahead and we're taking in our, well, I'll set the things so we have access to them. So we'll say self expression is equal to expression. Self delimiters is equal to delimiters. And then this guy will take in self.expression and self.delimiters. What's this guy complaining about? Let's save this. ShuntingYard, blah, blah, blah. Is it self? No, it's this in this language, right? Where were you on that one, Clancy? And it's not dots, it's arrows. Okay, and is it delimiters? There we go. All right, so now when I create ShuntingYard, I should get the exact same output. So we've just kind of moved our logic into this object. So let's go test that real quick and make sure that everything is copacetic. All right, and it is. Those are our tokens. This is displaying our queue, even though it looks like it's just the string. Okay, so now we're ready to start cooking. All right, so the constructor, oh, I got a chat. Oh, yeah, geez, Clancy, I agree. All right, so we'll go ahead and inside the constructor for ShuntingYard, we'll go ahead and actually just process all of those things. I don't think we need to like call a secondary function to do it, which actually maybe then gives you a reason to say maybe ShuntingYard shouldn't be an instance object, but a kind of like a singleton. But we'll just keep trucking here. This is good enough because it's going to remember the expression, the ops, so that gives us the extra ability that we might want to have. All right, so for ShuntingYard, and let's go ahead and get our ShuntingYard guy open here. Where is, looks like Chrome doesn't recover from shutdown very well either. Okay, so ShuntingYard. So we'll bring this up for reference. Make it bigger in here. Oh, wait. That. There we go. Okay, so we're going to need a couple of pieces here for our ShuntingYard to work. So we have our input queue. So now we need to have our op stack. So we're going to have a stack pointer op stack, and this will be a new stack. And we've already included stack HPP here. We're also going to need our output queue. So we're going to have another queue pointer. Output queue is equal to a new queue. So that'll be our output queue. And now we want to perform the ShuntingYard logic. Ultimately, this guy is going to give us our output stack. So we'll actually print it out in here because we haven't, for the homework today, we weren't to, we were supposed to get up to everything except doing the math. All right, so and then we'll do the math to finish up today. Let's see where am I at on time? Oh, we're good. All right, so for the ShuntingYard logic, we want to process off of everything in my input queue. Now, one thing I like to do, I'm gonna actually go into queue here. Right now, queue has a count, and then it has a display, and we have a way of getting in the line and getting out of the line. I like, for my data structures, because the way I like to write the function for it, I like to add a isEmpty function. It's completely unnecessary here since we already have count, but I like to add isEmpty that returns true if it's empty and false otherwise. It allows you to be more expressive in what question you're actually asking. So I'll put this guy in here, and he's just going to return, he's empty if this count is equal to 0. And this is a member of queue. And for, is bool not a thing? Put that. What is bool?
I think you typed it wrong in the CPP.
Well,
Yeah, I think.
Oh, it's actually this.
Yeah,
Thank
it
you.
is bool. It's the correct syntax.
Yeah, I just put, I forgot to put it on the left side of the thing here. Thanks for backing up Klancy there, guys.
Only human, man.
One for 4, Klancy. You're doing good.
I have to say the hardest hit to my ego, who was it? Was it Noah? Or was it Brocker that put in the thing that this has proved a couple of things that Lippmann's human with my bug in the stack. How do you know I didn't introduce those bugs there for your benefit?
Good point.
I think there's also some truth to me getting old. So, and stir crazy. Things aren't firing as well as they should be.
I think it has more to do with the quarantine than it does anything else.
Yeah. Doesn't matter. At least you learn from my bugs, so then it is instructive still. Okay, so I like to have a little function like this called isEmpty, and I'll explain why here in a second, but it completely is unnecessary because you could always write your loop around the count, assuming you can trust that count is accurate, my stack code. So let's go back here. So when we're performing the shunting yard logic, we know we want to go through every single element of my input queue. So I'm going to say while input queue is not empty. All right, so you see how this reads a little bit cleaner in terms of the question we're actually asking here. I'm asking, I want to keep doing something as long as my input queue is not empty, as opposed to saying something like this guy get count greater than 0. Perfectly acceptable. Nothing wrong with that. And a programmer can look at that and pretty quickly gather that, oh, that means that as long as there's still some stuff in there, I can do something with it. I just personally think that reads a little bit cleaner, just right off the bat, doesn't require any real thinking that, oh, we want to keep doing something until my input queue is empty. Okay, so as long as this guy is not empty yet, we want to process it. So we want to ask some questions about what is currently in the input queue versus what is, well, we want to get the first element from the input queue. And when I dequeue stuff, how does it come off? Does it come off as a string or does it come off as a node? I'm guessing a string. Dequeue is a string. Okay, so I get a string. So let's go ahead and get that. I'm lost. Okay, so we'll have a string temp here. And we'll go ahead and we'll set temp equal to input queue dequeue. All right, so we'll grab the first thing off the off that. Now we're interested, is this guy a number or is this guy an operator? All right, so we're going to go ahead and we're going to write another function inside of ShuntingYard HBP. We're going to make this guy a private function because we only need this internally, right? We don't need it outside of this to ask if something is an operator or something like that. So again, I'm going to say bool is operator, and this guy will take in a string as a parameter, and he's going to return true if that thing's an operator and false otherwise. So we'll go write that in here. All right, so I want to know, is this guy right here found somewhere in this delimiters? Okay, so I need to search through all the things inside my delimiters. Now, for us right now, we can make the assumption that this string is actually a single char. That is a assumption we're making, that this version of ShuntingYard doesn't have operators that are longer than a single character, but I think that makes sense. Plus, minus, times, divide. We're not doing the power yet, but we won't do the power because we'll get enough instruction out of this without that. And then parentheses. So all those things are operators, and they're just single characters. So what I'll do is right off the bat, I'll say char C is equal to S at bucket 0. So I'll go ahead and give myself that one character. All right. So now I want to loop through all of the potential operators that are inside of my delimiters. So for int I is equal to 0, I is less than, and we might even have a way of searching in this string for whether something exists or not, but we'll just search through it real quick instead of me going and looking that up. This is s dot length, I plus plus. Each time through, we're going to say if C is equivalent to S at bucket I. If that's a true statement, if this character is equal to the current character we're looking at, then this guy is an operator. So we'll return true. If we get through the entire for loop and we never run into that, we'll return false. I did not find this character C anywhere in the string. All right, so this allows us to ask whether a particular character is an operator or not. Okay. Now, we do have a couple of other things here. I also need to say, here, we'll write it out here. Actually, we'll write the logic up in the constructor rather than giving us an extra function for that. All right, so we have our temp. We're going to ask the question, if this is operator temp, do the op stuff. Else, if it's not an operator, it must be a number. What do we do with numbers? We enqueue them into our output stack. So we'll say output queue, output queue. Enqueue temp. So that's all we do if it's not an operator, right? So really the brunt of the homework is what goes between these opening and closing curly braces right here. All right, so far so good? Following along? Everybody except Klancy, I presume.
I don't even know what class I'm in right now, to be honest.
Can you scroll down to the is operator?
I cannot.
Please. Thank you. Is it going to return true every time if you set C equal to the first S at 0, the first iteration of the loop?
Oh, it will, because I shouldn't be using S here. This should be this delimiters dot length, and this should be this delimiters at bucket I, because I'm searching for this guy in my string of delimiters, not searching for this guy inside of S. So yes, the answer is yes. It would have always returned true the very first time through, in fact. But now I'm searching for this character inside of my string collection of delimiters and asking the question there. So now I think we're correct. That look better?
Yep.
All right, so do my op stuff. Well, what are the things that I should do for my op stuff? Well, right off the bat, we probably are interested in whether or not we're dealing with a parenthesis, right? Because we need to look at what are the rules associated with parentheses. If we see an opening parenthesis, what do? We instantly push that onto the op stack. That's more powerful than everything, right? So I guess real quick here. Well, if I'm inside here, we'll do it like this. So we're going to say char op is equal to temp at bucket 0. We know this guy is an operator if I'm inside this if statement, so I'll just put him into a char so I can work with them more conveniently here. All right, so we're going to ask the question, if op is equivalent to the opening parenthesis. If that's what I'm looking at, we immediately can just push it onto our op stack. So we'll say op stack, push op. Now actually op is going to take a string as a parameter, right? So the string version of this is actually called temp still. I think that's what I'm pushing onto my stacks or strings. Let me confirm. Push takes a string, it does. So I suppose we can decide whether this makes sense or not, because I'm asking questions about single operators, but ultimately my op stack takes on a string, so I know the string is called temp, so I can just push that back on, or I can turn my op back into a string. I think this will work just fine. All right, because my stacks require me to give it a string, so I'm giving it a string representation of that operator. All right, so if op is the opening parenthesis, then we're going to do that. Else, if op is equal to the closing parenthesis, what do? If the op is equal to the closing parenthesis, then we need, we're going to forget about this. We're not doing any pushing, but we need to pop off of our op stack until we hit an opening parenthesis, right? So we're going to go ahead and we're going to say, we could do this as a do while loop will be a good one for this. So we'll say do some stuff. What are we going to do? Well, we'll use our, actually we'll want a string, call this guy temp op. And we'll say temp op is going to be equal to op queue, or op stack rather, pop. So we will pop a string off our op stack. Now, what we're interested in is, now we could probably make the assumption here that this guy is not a opening parenthesis. Let me think about this. Yeah, I'm going to do this not in a do while loop. I'm going to do this in a while loop. So we'll go ahead and pop from the top of our op stack. We know that that guy, if we're assuming that they didn't give us a bad expression, we know that that guy's not the closing parenthesis right now. Actually, even if it was, this would still work. So we're going to say while temp op is not equal to, and actually what we're really interested in is temp op at bucket 0. Well, that guy is not equal to the opening parenthesis. What do we want to do with it? We want to enqueue it onto our output queue. So output queue, enqueue, temp op. And then we'll go ahead and pop the next guy. We'll spin back up. If it's still not equal to a opening parenthesis, then we'll enqueue it, because it's a normal operator. It's a plus or a minus or whatever. We'll enqueue it. We'll get the next guy. As soon as we finally get an opening parenthesis, we'll spin back up. Now we know we're at the end of reclaiming the operators that we need to make sure we do first, the things that were inside the parentheses, and we will not do any more enqueuing, because we're not gonna enqueue the opening parenthesis here. We just use that guy as a placeholder to match up to where our closing parenthesis was. Okay, so this code right here says, we'll say clear the op stack of everything that belongs to this closing parenthesis. So that's what this guy does. It grabs everything to the up to the corresponding opening parenthesis. All right, so if it's an opening parenthesis, we just push it onto the stack. No rules associated. If it's a closing parenthesis, we clear the op stack up to the opening parenthesis that was there and discard the opening parenthesis. Otherwise, if it's neither of those guys, what do? We have an operator and need to try to push onto the stack. All right.
I have a quick question.
But
For the parentheses, could we have solved that recursively? Like, would that be a problem that would have lent itself to solve recursively?
well, I would say you could solve it recursively. I don't know that it would have lent itself to solving recursively. Because we weren't doing operations inside of, I mean, because usually recursively would say, I need to wait for an answer from something. And presumably waiting for that answer means I'm waiting for some logic to be applied to something. And that might take, quote, a while. So in this case, we're just looking at a character and asking a question about it. You certainly could implement it recursively, but I don't think it necessarily lends itself to that. Does that make
Okay,
sense?
thank you. Yeah, thank you.
All right, so we have our operator. We want to try to push it onto the stack. And what are our rules? Is it greater than, or is it, well, let's see, we got a plus sign on there. We were able to put something more powerful than the plus sign. Okay, so it has to be stronger than the operator at the top of our op stack in order to push it on there. So we clear our op stack based on that. Okay, so we'll go back into here, and I'm going to go ahead and add to ShuntingYard another private function called what are we going to call this guy? Int get op power. And this guy will take in a string s as a parameter. Actually, we can call it a string op because we know it's an op. All right, so we have our get op here, or get op power, and we want this guy to return an integer for that guy's relative power. Now you can match up to their chart here that shows, like, you know, the weights if you want. This is fine. So plus or minus is a 2, divide or times is a 3, and power is a 4. We'll even put that in there in case we want to expand this. Actually, let's not confuse it. We'll leave that out. So we're going to basically ask the question, if, well, let's get our, let's do it real quick. So if this guy is equal to a multiplication, or is equal to a division, return a 3.
I hate to interrupt,
Yep.
but Jared mentioned something on line 25. There's a missing semicolon in the shunting CPP.
Line 25. Thank you.
Thank Jared. He's the one that brought it up.
All right, so we only have 4 kinds of ops in our world right now. So we have get op power for multiplication or division is a 3. Otherwise, it's a 2. And that is just going off of this little chart here. Really, you just need to make sure that the numbers you return for multiplication and division are the same as each other. and they are larger than the number that you return for addition and subtraction. And this will work. So, you know, you can use the exact same numbers they have if you want, which I did. All right, so this is my op power. Now this wasn't, you know, crazy logic or anything, but by putting it inside of a little function, now I have the ability to just call this guy real quick. So we're going to try to push something onto the top of the stack. So we're going to say while op stack, and actually I'm going to do something similar to what I did for the queue. I'm going to add a bool is empty to stacks. And this guy will just return this count equal to 0. So again, not necessary, but is a nice, we could also return whether or not this top is a thing. So we can say return this dot top. This dot top would be, so we would return not this dot top, would return true for it being empty. All right, so we just added that little ability onto stacks so we can ask the question here. So I want to say while not op stack is empty. So while it's not empty and let me look at where I had my, didn't I have an or somewhere here a few minutes ago? Yeah, I just, in my mind, I thought I maybe only put one vertical bar. Remind me, what does only one vertical bar mean? What would that mean? So if you have a bug in your code where you've only given it, well, potential bug in your code where you've only given it one vertical bar, this compiles. Actually, this wouldn't compile in the current, actually in C it would because these are numeric. What does a single vertical bar mean as opposed to a double vertical bar?
Is it like an exclusive or?
No, exclusive or is the power thing, this guy. So I probably, well, we'll see, maybe I didn't introduce it, but if I had, if you wanted to take 2 to the 5th power, let's say, or 5 to the 5 squared, you know, we might try to write it like this, but this is actually not going to give us 5 to the 2nd power. It's going to give us 5 exclusive or 2, but this is a bitwise exclusive or. Have we ever talked about that before?
Bitwise? I don't
All right,
think so.
I don't think so.
all right, let me show you that real quick.
It's on C. It's on the C plus. I see the document for the bitwise functions.
Oh, here, let me just show you real quick in another function. Do I have a test.cpp somewhere? Oh, I'll just write it out here. Well, let's see. I'll put it into because I'm just in the middle of writing some code. So let me, for a moment here, just comment this out for a second. I think this will compile now. Okay. And then let me just write some stuff inside of driver. We'll just comment that out so we're not dealing with it. So I'm going to go ahead and I'm going to say int a is equal to 5 squared. 5 times 5 is 25, right? So we expect a to be a 25, but it's not a 25. It's a 7, obviously. So then the question is why is it a 7? So let's go back here. Note. Open recent. This guy is not 25. Instead, it's a 7. Why? So this is a bitwise operator. This is the bitwise exclusive OR operator, in fact. So this guy is the bitwise XOR operator. And I'll also put in this guy is the bitwise OR operator. And this guy is the bitwise AND operator. So a single ampersand or a single vertical bar or a single caret like this, the double caret is exclusive OR, are the bitwise operators for those. Now, what does that mean? It means we actually perform that logic on a per bit basis. And it's actually something we use quite a bit in computer organization, architecture, operating system design, things like that. So I won't get too much into that, but I'll show you how it's actually working. So a 5 is a 1, 0, 1, right? So this is a 1's place, 2's place, 4's place, so it's 4 plus 1 is a 5. A 2 is a 0, 1, 0. Okay, so everybody's cool with that. This is the binary version of 5. This is the binary version of 2. So now what we do is we provide, do the exclusive OR on a per bit basis. Remember, exclusive OR says one or the other, but not both. So that means if I had a 1 XOR 1, it's a 0 because I can't be both of those. So a 1 XOR 0 is a 1. A 0 XOR 1 is a 1. A 1 XOR 0 is a 1, and that's equal to 7. That's where that 7 comes from. Similarly, if I were to say this guy, or let's see, ANDed with these two guys ANDed together, this would be 1 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, so it would be a 0. If I came back out to our code here. And I changed this from that to an AND. We get a 0. If I change it to an OR, we still get the 7 because the output is the same. If this was an AND or an OR, or if this is an XOR or an OR, we get the same output from this bitwise operation. All right, so does that make sense how bitwise operations work? Not so much what they're for at this point, but how they work. So at this point, just consider them to be a mathy thing that you might use at some point in time. If you want me to just give you a quick little thing, let's say that you have a, in your computer, a hardware register. So like a, so let's say they're using a 8-bit memory location to store 2 hexadecimal values. Well, if you want to get the first hexadecimal value, this guy here, well, this would be the second hexadecimal value, I guess. So if I want to get just the 1111, I need to turn these guys into zeros. So what I would do is I would bitwise AND with all of those. And I would end up getting, actually, I would bitwise AND it with that. So bitwise ANDing it with that will give me, let me actually just switch that to a 0, just so you can see that it preserves that side. So 0 ANDed with anything will be 0. And then over here, we perform the normal AND. So 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. So now what we've done by bitwise ANDing this entire 8-bit number with the first nibble being all zeros and the second one being all ones, we give ourselves just what that right 4 bits was. Does that make sense? And if we want to get just this left side of it, what we do is we take that number and we right shift it by 4. This arrow thing says shift all the bits to the right. So what that'll do is it'll give us 0, 0, 0, 0, 1, 0, 1, 1. So each one of these bits gets shifted to the right. So this 1 disappears, the 0 disappears, the 1 disappears, the 1 disappears. These guys move over by 4 and we leave zeros in the wake. So now we can read that left 4 bits for our other value. So bitwise operators and shifts are used for accessing certain areas of a CPU's hardware register when we choose to use the 8 or 16 or 32 bits to store more than one value instead of using the entire register to store everything. So I'll ask if that makes sense, but I'm not going to go into it any deeper than that. But that's the applied aspect of bitwise operations. All right, and the reason I bring it up here, I probably meant to bring it up at an earlier time, but it has to, it just occurs to me as we run into a situation where it could be a problem, is a couple minutes ago, I asked myself, just in my mind, when I wrote the double ampersand inside of ShuntingYard, wherever it was, right here, when I was writing this, it kind of occurred to me that, oh, did I remember to do a double vertical bar down here? Because what ends up happening is if you don't do a double vertical bar, depending on if you were in Java, this wouldn't work. But in C++, because these are numeric, this would work. This would be a numeric 0 or 1, bitwise ORed with a numeric 0 or 1. So the problem is you would not get an error from this. You would just get the wrong answer. So it might be something that's very difficult to debug because you wouldn't have some error yelling at you, not allowing it to compile. It would still compile. So that's the bitwise operator lesson. All right, so any quick questions on that stuff without going too much into depth of big use of those things? Okay, so back to here. If we have an operator, we need to try to push it on the stack. So while the stack is not empty and we want to ask the question, the top of the stack is more powerful, well, is at least as powerful as our current value. So we'll say our op stack peak. Ay, ay, ay. Ay, ay, ay. So that is the top of our op stack as a string. We now have a function called getOpPower. So we'll say, I'll just cut this for a second. We'll say this getOpPower, passing that operator. So here I'm going to kick this down a line so it's a little bit easier to read here. So right there, well, that guy is greater than or equal to the name of my op here is called temp. This getOpPower of temp. So while both of those things are true, so while my while the power at the top of the stack, the op stack, is at least as big as the thing we're trying to push on, what do we need to do? We need to pop it off of the op stack and then queue it onto our output queue. So we'll have our output queue, enqueue, op stack, pop. As soon as we survive that, when we are here, we know we either have an empty op stack or I can freely push temp onto my op stack. Well, either way, I can freely push temp onto the op stack. It's either empty or the guy at the top of the op stack is weaker than me, than temp. So op stack, push, temp. All right. So that's what we do for our operators. If it's an opening parenthesis, push it. If it's a closing parenthesis, ignore it, but pop until we find the opening parenthesis. Otherwise, if it's an operator, get it pushed onto the op stack appropriately after we've appropriately popped from the op stack things that have a greater order of operation. Otherwise, if it's just a number, we just enqueue it. Once we're past here, remember we're outside of our input queue being empty, so we're done processing our input queue. So done processing input queue, now clear the stack. So while op stack, well, this guy is not empty, output queue, enqueue, op stack, pop. And then in the end, we should be able to say output queue display to show us our final output queue. Okay. So let's go back into driver here. So we should get a 123, a 42, an 8, a times, a plus, and a minus. That should be our output. So does that look right? And the math for this guy should be what? A 8 times 2 is a 16. And then we have, let's see, 123 plus 42 is 165. 165 minus 16 is 149. that right? I think that's the right math. Klancy?
Looks good.
All right. So this guy should be a 149. So I think at this point, our homework is done, right? This is the output for our homework. This is our output queue. All right. So now, any questions about that? So that's the homework for today. And I can even do a GitHub push.
Yeah, I have a question,
Okay.
but I'm bringing it up right now because it's a term. So like I tried to do this, and for some reason it gave me this. I looked this up online and I couldn't figure it out. It gave me an error that said it actually compiled, but then when I try to run it with a.out, it says terminate call after throwing an instance of stud, the two dots, logic, error, what, parentheses, another two dots, and then basic string, m construction, null, not valid.
You have a bug with your how you're using your strings.
Oh, okay.
Complaining about something you're doing with the string class.
Okay.
So if you want to stay after, I can look at your code or message me on Slack later. I can take a look at it and tell you what the issue is.
Yeah, I can. So you're saying it's, yeah, that's what I thought too. I just wasn't sure what it was.
Okay. So now we have our output queue. So now finally we want to do the math. So doing the math for ShuntingYard. If we look at this as our output, here, where is it? Oh, here. Actually, it's that. You think you're better than me? All right, that's that. All right, so if we assume that this is our, this is what our output queue looks like. So now what we want to do is we are going to use a stack to do the math. All right, so let's just see how it works first, and then we'll write it real quick. So we have a number. What do we do with numbers? We push it onto the stack. We have a number. What do we do with numbers? We push it onto the stack. We have an operator. What do we do with operators? Well, we need to pop from the stack twice and perform that operation. So an operator, like the plus sign, requires two inputs. So we'll pop the 123, we'll pop the 42. So we have 123 plus 42 is 165. So we pop, perform addition on that, pushing the result back onto the stack. So we have 165.
Does a problem arise though when you have the 123 and the 42, getting those to line up where you need them to? So for example, like the 123, shouldn't that be on the left side of the plus and the 42 be on the right?
Well, it only matters if you're doing subtraction. So in actuality, what you're saying is this, where we push the 123, so then we have the 42 first and the 123 second, because we push the 123, then we push the 42 on top. When we do the addition, what are we actually doing? We are saying, well, here, I'll actually just push the addition. So we're going to push the addition here, which means we need to consume the operator plus the next two things. So this guy is actually going to be a 1, so it's going to do is a 123 plus a 42. That's the math it's going to do. So we're going to pop the 42, and that's going to end up being on the right-hand side of it. And we're going to pop the 123, which will end up being on the left-hand side of it. So if we pop these guys into, you know, int1, then int0, you know, two different variables, then we can add int0 plus int1 together, and they'll be in the right order. And this only matters, it won't matter for addition or multiplication, but it will matter for division and subtraction. So you're right, we do need to keep track of what's technically on the left-hand side and what's technically on the right-hand side, so we do the math the right way. All right, so this is going to give us a 165 that we then push back onto the stack. So we have the empty stack there, push that back on. Then we hit a 8. What do we do with numbers? We push it onto the stack. Then we hit a 2. What do we do with numbers? We push it onto the stack. Then we hit a multiplication. So multiplication makes us consume the top 2 things from the stack. So this is going to be a 8 times a 2, which is a 16. So we consume the top 2 things, perform multiplication, giving ourselves a 16, pushing it back onto the stack. Then we hit the minus. What do we do with an operator? We consume the top 2 things from the stack. So this is going to be 165 minus 16. So this is where we have to be careful, Clancy, you're right. So that's going to be this guy. The answer to this guy is 145. That's after we've consumed these 2 things, pushing that answer back onto the stack. Now we're done with our output queue. That guy's empty, and our answer is at the top of the stack. Except I did the wrong math there. It's 149, right? All right, so that's the logic we need to do there. Now, we do have the challenge of getting numbers out of our strings here, right? And there might be an operator for getting a string out of or a number out of a string, or we can just write that real quick. So let's just write that real quick so we can save some time. So we'll just put it inside of ShuntingYard. We'll have another private method here, int, and we'll call this guy string to int. He'll take a string num as a parameter. We'll go write this guy. Right, and this is our old base to decimal. So we're going to convert a decimal string into a decimal number. So we'll have our int sum, starts off at 0. We're going to start off at the end of our number. So for int I is equal to num.length minus 1, I is greater than or equal to 0, I minus minus. Each time through, we want to get the position of num inside of a, so this is where we would do our index of thing. So again, I'm not going to look that up. So I'm just going to write that real quick. Int index of, going to take in a string s and a char c. So this should start showing the power of programming in that, yeah, there's probably already a function built into the string class to go and search for this stuff real quick, but I'll just write it myself quickly. What is index of going to take? It's going to take a collection and a char, and we're going to go through and we're going to say for int I is equal to 0, I is less than s dot length, I plus plus. If s at bucket I is equal to the character we're searching for, we'll return I. That's the position we found it. If we went through the entire thing and we didn't find it, we'll return a -1. So index of will search for this character inside of this string. It'll look through the entire string, returning the index within that string where it was found, or a -1 if it wasn't found. So that's what index of did in Java, and that's what it does now in our C because we wrote it. So string to int here is going to say, we're going to have a string nums, it's called the numbers, is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So a number that's at bucket 0 would be a 0, a 1 is a 1, a 6 would be at bucket 6, so on and so forth. So it'll give us the number for that. So each time through, we'll say sum plus equals this index of the numbers and num at bucket I. So I'm searching for the character I'm currently looking at in the string. Inside the numbers, this will give me the index of that guy in there, which is going to give me a numeric. And then we're going to have an int place is always going to start off with the ones place. This will be place times this guy. And then place times equals 10, because we're dealing with the power of, we're doing a decimal, which is base 10. So we'll return sum at the end, which should be our numeric version of this guy. And then finally in our constructor up here, where we're actually going to do the math, so do the math. So we're going to go through while output queue is not empty. We need to do stuff. What are we going to do? Well, we're going to need a math stack. So we'll go ahead and create a stack pointer, math stack. And this guy will be a new stack. Actually, I already have a variable called temp from up there, don't I? So we'll say temp is equal to, because we don't need it from up top, we'll just repurpose it here, is equal to output queue DQ. Then we're going to ask if this is operator of temp. So if temp's an operator, then we need to get our two things. So we'll say int num1 is equal to math stack pop, but that's going to come out as a string. So we're going to say this string to int of that guy. So look at this, the numeric version of that. This will be the numeric version of this guy. Then we'll perform the math. So the math in this case, and I know we're out of time. I'm going to be done in about 2 minutes. So I'm just going to keep cooking. But if you need to run, it'll be on the video. It's Easter break, so no homework. The next time I'll see you is next Tuesday. Remember, your classes on from after 4 p.m. on Wednesday are not canceled, but they're not meeting because of Easter break. So Thursday and Friday you have off, and also Monday you have off. So I'll see you on Tuesday at our normal class time. But I'm going to keep cooking here just to finish this real quick. I just need to do the math at this point. So I'll actually, inside of ShuntingYard, I'll just have a little int do math that takes a char op, a int num0, and an int num1. And this guy will say if op is equal to plus, we'll return num0 plus num1, else if it's minus, minus, else if it's times, times, else if it's divide, do divide. So that's our do math. So now we're going to say math stack push, and we're going to be pushing a string onto this guy. So we're going to say this do math. The math we're doing is our temp. I have it taking in a char, right? So temp at bucket 0, and then num1, and this is actually num0. So it's in the right order. Sorry, num0, num1. All right, so for do math, this is going to give us the correct math there, but it's going to give it to us as a int. I'm going to go ahead and concatenate that onto the empty string, and then I'll typecast that guy to be one of our more modern strings, and we'll push that onto the math stack. All right, so we'll do this over. So if we run into an operator, we do that. Else, if it's not an operator, it must be a number. What do? We dequeue and we push. So math stack, push, output queue, dequeue. We just add the number to our math stack. And then when we hit an operator, we consume two things for our math stack, do the math, pushing the result back onto the stack. Once we've done doing this with the entire output queue, our final answer should be at the top of the math stack. So we'll do a cout, math stack. We can actually just do a peek and leave it at the top of the stack if we want. So this is that same error that you were getting in yours. This should have worked. Turning that back into a string. Oh, it's actually complaining about index of. And string to int and do math. I did define them, didn't I? ShuntingYard, string to int, index of, do math. Do I save this file? And then ShuntingYard. This needs to be ShuntingYard. Killing me, Clancy.
There's two of them. There's two of your files that are unsaved. Yeah.
Oh yeah, I see it. Index of. rest of these good, yep. And then driver, we'll save that.
That's what I saw. That's what I saw.
Right, yeah, that's what I was saying. So it's not liking the way I'm doing concatenation here.
Okay.
Null, not value, not valid. So I think we saw last time that we can just do a was it like a toString, int to string, something like that?
Could we just add the empty string as well to turn it into a string?
That's what I was doing. That's what I had here. I was concatenating on the empty string onto the result of do math.
So what is string in the parens doing?
This
Right there.
this is turning, because this double quote, this guy existed a long time ago, way before this string class existed. But my push here requires me to pass this newer kind of string. So this is saying treat this guy here as one of these.
Okay.
But actually, maybe what I need to do is that on that guy. Treat this guy as the empty string, actually as a string, then concatenate onto the rest. Yeah, doesn't like that either. I think we saw last time that this doesn't work, just doing it directly like that, unless it typecasts it as it's going in. Yeah. So I think we saw last time that there is a function in string that's like, what is it? String dot like int to the int to string, something like that.
I thought the name of it looked a lot more ghetto than that. I thought there was like an underscore.
Really?
Yeah, if my memory might be playing tricks on me, but
String, that guy. Where is this complaining? Oop. Let me do this. Int answer is equal to, just so this looks a little bit less janky in here. All right, so that's our answer. And then we need to get that guy as a string. Make sure I get the same error again. Yep. And then do I need to turn this guy into one of those? No. Let's just make sure this is where the actual error is. I'm just going to hard code in a 5 to push back in there. It's going to give us the wrong math, but this should give us the oh, not valid. Oh, good. So where is it complaining? Is it in our string to int? Funny thing is all of our logic's right. The whole problem is just getting an integer back to a string. Let's see. String to int. No, this guy seems fine. So we write our own int to string. Oh, that was definitely built in. Let me just make sure it's in that code I just deleted real quick. It's not. Interesting. It's not in that code. Basic string. It'd be so nice if you told me where it was.
Hey, Littman, I got to get heading out, but are you planning on pushing this to GitHub?
Yeah, I'll push it to GitHub at the end.
Okay. Hope everyone has a good Easter, even though we're not going to be able to see our families much. So talk to you guys later.
That's depressing.
Yeah. Yeah, see, this is the same problem I was having. I just didn't understand like why it was continually giving me this error.
Well, I'll find it here. I'll find it here.
Okay. Well, I probably have to leave too soon.
That's
So
fine. Yeah, so I already know now where the code is, where the issue is.
okay.
So it looks like it's in stack pointer math stack equals new stack. That's the only thing I changed.
Talk to you soon. Press for the movement.
Okay. Okay, so it's that line right there. This line. So output Q, DQ. What does our output Q look like? Yeah, this was the thing that should never happen. I think this is what's happening. In fact, if I get rid of this, I bet we get a different error. Same error. Oh, are we getting spaces? Let's see, driver. No, should be a spaces. That's fine. happening right there on that line? Instance, okay. Oh, hold on. Did I do this twice? Did I make the same stupid error twice? That would totally be on Klancy too. No, I decrement DQ there. So what's happening is I'm calling DQ one extra time. It's giving me a null value the very last time through. We can see that it gave me all those operators, but then it's trying to DQ one more time from the thing, which means that go on here. So while it's not empty, DQ it. Oh. Klancy. Well, actually, I could say I'm going to DQ it regardless, but I don't DQ again here. I just give it temp. I was DQing double instead of using the value I already DQ'd. Oh, I'm still hard coding in the 5. 1 second. So this is going to be, let's just confirm that I can't do this. I think we saw last time that that's not allowed. But it's possible since it takes a string as a parameter, it'll fly. There's our 149. But I still think we can concatenate better here. I think I can do string, empty string, like this. And then I can concatenate onto that my answer. And that will build me a string. I need one more opening. Oh, that doesn't allow me to concatenate on ints anyways. Okay, well, we'll call that the final correct answer. Well, except I can't do anything on that terminal right now. Oh, that's good. That's even better. CPP. Got out. There's our 149. All right, so just to show you real quick what the issue was, is I was DQing here at the very top of this guy, which worked great inside here. But then whenever I had something that wasn't an operator and I was just outputting it, or I was just pushing it onto my math stack, I was DQing again here instead of just using the temp variable I already had. So I was doubly DQing whenever we had a number, which means I was running out of stuff. which meant that then when I went to do the math and I was popping off the stack right here, I didn't have enough stuff on the stack to pop to do the math. But now it has everything there it needs. All right, questions, comments, concerns, bribes? All right, have a good Easter, and I'll get this uploaded and